Hello everybody, Chris here, and in this video we've already pretty much got the character controls for the player's state machine already working and going with input and the states. So at this point I think we're ready to move on to the enemy's behavior tree setup using LimboAI. So one quick fix I want to make before we get into that, if you look at the character's ground attacks, you'll see that it reverted its movement back to the regular run speed variable. So if I click on ground attack, in the last video, we set up a movement speed variable, so we can set this to a different one on the character stats. If we click on the root and look at the stats, we wanted attacking run speed to be the variable here, not run speed. So I just need to get this property. I can right click and copy the property path, I think, and go over to ground attack and just paste it in. Yep, there we go. So if we hit play and we start attacking, you'll see that it's using the slower attacking run speed for movement during the ground attack state now. It was working like that before, but I guess it must have got reset at some point somehow. So anyway, that's fixed. So let's move on to the LimboAI for the enemy. So in the characters enemies folder, I'm going to open up the Krabby scene. Right now, there's not much in here. We've got an animated sprite 2D. We have all the animations imported by using a sprite wizard, which basically just converts the a sprite file into a animated sprite 2D. And then in the animation player, we can see that I actually have all of the animation names imported here. They're all currently blank. So these were supposed to be not here. I think it was from some test script I was working on before starting the series. So I'm actually just going to go up here to edit the animations and just delete that whole library. We'll recreate it, if not in this video, in the next couple for the animations we need. So just want to remove that so it's not confusing for anybody. Okay, and now we want to add in the behavior tree finally for our character. So I'm going to right click on Krabby. We're going to add a child node and we want to search BT for behavior tree. So we want a behavior tree player, which is essentially the root of our behavior tree. We'll create that. Now you'll notice that there was no behavior tree node that gets associated with here. Instead, behavior trees using LimboAI use resources instead of nodes in order to create the tree. So other behavior tree plugins like Behave would use a node-based approach. Both can work perfectly well. I just wanted to point out that distinguishing factor. So to start creating our behavior tree, we can see in the inspector of the BT player, of course, it's an empty behavior tree right now. So if we click on this and hit new behavior tree, and we click on behavior tree, it's going to jump over to the LimboAI behavior tree editor. You'll see a whole bunch of tasks over here on the right, and these help us to set up essentially the AI for our character. We can also see that at the bottom, we have a little warning, task folder not found, resources AI/tasks. So that would be the default path for where we have our Blackboard tasks stored if we want to create custom ones that we use in our behavior tree, which will be set up here. So if we click edit path, you'll see that it mentions that for the GD extension version, at least, we have to navigate to project settings. So we could do that real quick. And then I think if we scroll down here to the bottom, you can find LimboAI behavior tree and set the directory here. Or if you prefer, you can just hit create and that'll automatically create the AI tasks folder. So if you need to create a behavior tree task, a script that extends it and has its own custom code, which we'll probably do during the remainder of the series, then those just go in here so they can be found and recognized in this window over here. Okay, so for now, what I want to do is take this new behavior tree we just created, and I'm going to right click and save it into our characters folder, enemies, Krabby, and we could just rename this something like Krabby AI or Krabby behavior tree, whatever makes sense to you, just so that as we're editing this, if for some reason the reference ever gets lost on the inspector of the behavior tree, that we don't lose our entire behavior tree setup. That would be pretty bad. So I do recommend saving these directly to the file system so it is not tied to anything specifically, but it just is a file on your project. And as long as you don't delete that file, you can always recover it. All right, so one of the first things we're going to need our character to be able to do on the level is to navigate to a new location. So that, for this character at least, will pretty much just mean going left and right, for now at least. So we're going to need to tell NavigationAgent2D to try to go left and right until it would, let's say, hit a cliff or something of that nature, and then stop, maybe reverse or jump over the cliff. It depends on how we want to set up the character. Before we get into that, I do want to set up a couple animations and just make sure it defaults to the idle. So let's go to the animation player and we'll hit new. I'll just say idle animation. We're going to add a property track for the animated sprite 2D, the animation, where on the first frame, we click here and we'll set the animation to be idle. Okay, so now if we play that animation, okay, it should go back to our idle first frame at least. I also want to take the snapping and change that to 0.1 seconds. It gives us 10 frames per second for animation. Enable timeline cursor snapping. And now we can add the property track for the frame. So this is very similar to how we were working with the clown nose player because this is also animated sprite 2D based. So insert the key. Let's make sure this snaps to the 0, 0. And that's going to be our first frame. Next frame at 0.1 seconds. Insert key, change it to 1, and just do that as long as we have frames of animation. To see how many frames of animation we need to cover, click on animated sprite, go to the idle, and you can see there is 9 here. Starts at 0, so 0 is the first frame, plus 8 gives us 9. Animation player, we just need to keep doing that. So insert key, make this a 3. Next one becomes a 4. Yeah, this should be a 2 right here. 3. Okay, if it's not actually setting the value there, it might be because the animation is playing. So go to the animated sprite 2D and hit stop. Then we'll go here and change this to 2, hit enter. Okay, seemed like I accidentally renamed the idle animation to just S, so make sure you don't mess with the animation names there. Let's go back here and hit play. Okay, now we should be able to click on here. We get frame 2. Here we set to 3. Here we set to 4, and keep doing that all the way up to 8. So let's do 5 here, and then 6. Insert key, 7. Insert key, 8. And then stop the animation at 0.9 by changing the duration over here to 0.9 and enable looping, hit play. And there's our idle animation playing on the animation player. So let's duplicate this for the move. I'll duplicate and we'll have move animation. We click on the animation track and change this to run. So if it makes more sense, we could actually rename this animation to run as well. And we can see that this only goes up to frame 5. So I'll delete these extra frames and I'll cap the duration at 0.6, hit play, and there's our run animation. I mentioned we need a navigation agent in order to navigate the game world here. So let's right click on Krabby and add in a navigation agent 2D. So this is going to use pathfinding in order to find the final destination for where our character needs to go. And more or less what we just need to set on the navigation agent is the destination we're trying to get to. And then it uses, I think, an A-star algorithm internally in order to find its path to the destination. So we will need to set up the game level to be able to have navigation enabled, giving it a area where it can navigate in and handle the collisions here on the navigation map as well. But it's actually not too bad to get that set up with the default nodes in Godot. So on the BT player, the behavior tree, we're going to need to know about the navigation agent so that our behavior tree logic can tell the navigation agent where it's trying to go to based on whatever inputs we give it. So you can either add the navigation agent onto the blackboard, which would look something like this, clicking on the BT player, expand the blackboard plan, and edit it, and then add a variable, let's just say navigation, and then we could say node path here. With node path prefetching enabled, it'll get the actual node once the player initializes. And then you can just assign that to the navigation agent. And then now you have access to the navigation within the blackboard here. If you think that every enemy is going to be using this kind of setup, though, it may make some sense also to kind of go the route we were going with the player, where we just have a character, or in this case, it'll be an enemy that extends character, has some properties that are preset. So once we have access to the agent and then we cast it as an enemy, then we already know we have access to a navigation agent because every enemy has a navigation agent. I think that might be the way I prefer to go this time. So I'm going to remove it from the blackboard, and then we don't need to worry about it being on the blackboard at all, because we'll just have it on our enemy script. So let's add in a new enemy script. I'll attach a new script to the Krabby, and this is going to extend character, and this will be enemy.gd, and we'll save it in the enemies folder instead of the Krabby specifically. So create the enemy script, and I will give it the class name enemy. Oh, you know what? Even better, we could just call it NPC. So let's find enemy and rename it NPC. I'm going to take NPC script and I'm going to move it to characters. That way, if we had any neutral characters in the game, they could also have the same navigation system. So just making it like as generic and wide branching out as possible, I think makes some sense here. So this is going to be for any character that's not controlled by the player. We want to have a export var for navigation, which is a navigation agent 2D. And now on our Krabby, we can just assign the navigation agent 2D. And now if we want to get access to this navigation, we just need to cast the agent as an NPC. So let's see. In AI tasks, we could create our first task for navigation. So let's go to AI tasks. We create a new script. It's going to be, let's say, navigate to point. You could call it underscore task if you want, but I think it's already implied because it's in the tasks folder. And this is going to extend BT action, I think was the one we wanted. There's also BT task, which is more of the parent class, but because we're taking an action here, we want the character to actually navigate and follow through moving to the point, that this is something that's going to take over multiple frames. So BT action, I think, is the base class we want. So we can open up this script for editing. If we look at LimboAI, we should already have the task under miscellaneous here. So it's put under miscellaneous because we don't have another parent folder. So we might want to do like right click here and say folder navigation or something like that, and then just move navigation to point into that. And I think the next time we look at this LimboAI window, it'll automatically update. So now it's under the navigation category. That might make sense if you're going to have multiple navigation tasks. So you can just organize your folders like that so that they show up here how you want them to. So if I right click on the BT action symbol, lookup symbol, and go to BT task, which is its parent, then you'll see that there's a bunch of methods that we can override. And it's going to look a lot like a state machine node here, right? Because we have enter exit tick, which runs when the behavior tree is actually operating on that task. And then setup, we're going to want to make sure we grab the navigation node from the agent. So let's go navigation to point. Let's implement our setup function. We could say something like var npc is of type npc. And when we enter the setup for this function, we're going to take the agent and cast it as a NPC. So NPC equals agent as NPC. And then we already have the npc.navigation here because NPCs all have a navigation property. So when we enter this node, we want to pick a new point to navigate to and actually get there. So function, this is underscore enter. And we could say something like pick destination. So what are we going to do in pick destination? We're going to pick a new point that the NPC can navigate to. So for our navigation, we might want to just pick a random point, either to the left or right with a max distance. And when it gets to that point, it's going to stop and move on to the next AI task. So let's say in the inspector, we can just do like a max distance, which is going to be a float. And we could default it to like 200 pixels. Whatever the value you think is good, you can always change it because it's an export. And this will be the max distance to the left or right from where it currently stands. So to pick a new destination, we need to know the current position. So let's get the current position. And that's going to be equal to npc.get global position. Okay, I think that will work here because, yeah, right, because every NPC is a character body 2D, which is a node 2D, which has get global position as a method. So we have the global position, and then we need to pick a random value between -200 and +200, plus or minus the max distance, and try to navigate to that from the current position. So let's create a random number generator, I think. So RNG, random number generator, we can say RNG equals random number generator.new. So we get that, and then we need to get the offset. So if our offset is going to be equal to RNG dot random float range, and that's going to be negative max distance to positive max distance. Okay, and then we get that random value, the offset, we just add that to the current position dot x. So the new destination is going to be a vector2, which is going to have the current position dot x plus the offset, and then the current position dot y. So let's return the new destination. So this function will return a vector2. And once we have that destination, we're going to set the destination on the navigation. So npc.navigation dot, I think it's called dot, let me scroll down here a bit. What was the target position? Hold on, is it target? Yeah, okay, target position. So the property you want to set on the navigation is target position, and we set that equal to whatever we get from pick destination. And then from there, we just need to move the character towards the destination, or towards the next path point, rather. You'll see more about that visually when we have this running and we enable visible navigation. But yeah, it wants to move to the next point in the path, which eventually gets us to the destination. And we want to keep doing that until the navigation says that we are at the destination. So we're going to be running all of that on tick. So the tick function is kind of like update on a state machine state, or it's like the process function on any node. This only runs when the behavior tree is currently acting on this script. So the behavior tree will have a big selection hierarchy to determine what step it's trying to actually do for the AI of our character. So like before we get to, let's say, the player position, we have to navigate there. And then after it detects that we're at the player, we can start attacking the player, that kind of thing. So it's just a hierarchy of commands that one has to occur before we can continue with the chain. So let's see, for function tick, you want to return a status. So the status is either running, success, or failure. Generally, if the status is running, it's going to keep looping through this tick until it gets to a success or failure. If it's success or fail, generally, it either moves on to the next action on your behavior tree, or it's going to return back out so that it can select from a different part of your AI. And that depends on, if we look at the LimboAI here, that depends a lot on how you set up your composites here for what happens on success or failure, or if like all of the nodes have succeeded or failed, then you move on to something else. And it can get a little confusing, and there's definitely a learning curve to it. Okay, so our navigation to point. We want to check first if the npc.navigation is navigation finished, then we'll return success. So the status code is just either success, failure, or running. We could also say here if npc.navigation. There's one for like if it can still get to the point. So let's see, is target reachable? Yeah, okay, there we go. So if the target's not reachable, and I'm going to put a not keyword here, then we're going to return failure because there's no way for our character to actually get to the point it's trying to navigate to. So we're just going to stop trying to attempt that. Otherwise, we're still running here. So at the end here, we'll just return running. And then somewhere in here, we want to have our movement command. So let's just say something like move, and then we'll have to create a move function. Okay, if we click on Krabby and we look at its root, you'll see that there are also stats of the character. I'm not sure, did we create stats yet? No, we didn't. So we could create like a new NPC stats or character stats. For now, I think we can just make it character stats. So that gives us all of these move speed values. So we'll use that in our move command here. The character, I also want to assign the animation player and the sprite node so that we have access to those later. We may need it in some of these behavior tree scripts. So when we move our character, first we want to know the direction to the next point. So let's say our move direction is equal to npc.navigation.getNextPathPosition. And we could say the npc.globalPosition.direction to the npc.navigation.getNextPathPosition. And if that's too much for one line, then we'll just move this out to its own line. then we can say up here something like var next path equals, Control V, paste it in. So we're going to get the NPC global position direction to next path. Okay, so we know the move direction. Now we need to create the move vector. So let's say new velocity is equal to the move direction times the NPC dot stats dot run speed. Okay, and we don't need to worry about delta because we're using move and slide, so that's already automatically calculated in for us. So we want to do the NPC dot move and slide, but we haven't set the velocity yet, so we have to do NPC dot velocity equals the new velocity. That's gonna give us our move, and we don't really need to return anything for right now, so I'll just not have a return. We'll just execute that. So we have move here. Our character's going to try to move. Okay, and that at least is the base of our script. So I'm going to add into LimboAI now. So in here, let's start with a sequence node. So a sequence node is going to do all of these tasks in order until they are all finished or one of them fails out. So the task we want to try to do is navigation to point. And we already have our max distance here. You can customize the names to be more descriptive. So by default, it's just going to show the name of the script, basically. But it could show something like navigate to a point within. Well, it would be easier actually to just show the code. So let's actually create a override for that. So let's do function underscore generate name, and we're going to return the name, which is going to be navigates to a new point, max distance, let's say %s, to the left or right of where the character is. Okay, and then to replace this %s with a string, I'm going to do % at the end and say max distance. Okay, now if we look at the LimboAI and maybe I have to go back into it. Oh, let me actually try reloading the editor real quick. It should show. Okay, we look at LimboAI, click on our BT player, click on the Krabby AI, and it's not. Is there an error? Oh, yeah, right. Okay, so scripts can't actually work in the editor until you add the @tool at the top. So we just have to go up here and say @tool. So this means that parts of our code can actually run in the editor if we decide to call on the different functions. So the generate name will call automatically inside of the behavior tree. So if I click back on LimboAI now, and I click around a couple times, this will refresh. So now it's going to show something much more descriptive. Navigates to a new point of max distance, 200.0, that's the max distance, to the left or right of where the character is. So I think using generate name in that way just makes it a lot more descriptive what your character is actually trying to do. We could rename this sequence to be our, I don't know, find targets sequence or something like that. Okay, now as things are right now, if we run, I would expect to get a bunch of failures because we don't have a navigation map inside of our game. So if I hit play, you can see that it's immediately going to return false, even if we have picked a destination out. And let's see if there is actually a destination. If I click on NPC navigation, does it say anything about our destination? I think in the inspector, it doesn't actually show up here because it's not an export variable. But what you could do is you could say print npc.navigation.target position here, hit play, and we should get something in the output. Yeah, you can see that it keeps re-entering this script, right? Because it's the only script in our sequence. This one fails, so it tries to go back up here and start over, which means that it's just going to keep going in here and setting a new point. Destination fails, goes back in here, so on and so forth. So not entirely helpful for us, but at least we know that it's running as we expect it to at this point. So you want navigation inside of your game. That means we need to have a navigation map layer. Let's see, what was it called again? If we add a new child, navigation region. I think that's what we want, right? And then if I recall, you create a navigation polygon here. So let's create that. And our navigation polygon, we just put the points for our level. Basically, just to make it simple, we can just put our bounds for the navigation around the outline of our level and just kind of try to snap them, make them straight and even. Of course, you can always adjust the points later. Okay, so I'm not sure that one connected, did it? Can I see the points here? Okay, and to make sure that it actually connected, if you drag this, it should move both handles to the left and the right. Okay, yeah, so there we have our navigation area. So right now, wherever it's showing the slight blue, that means that it can navigate those regions. If we do bake navigation polygon, you'll see that you can see that the walls here are still considered navigatable, which is not good because that's going to result in our character running into the wall. Okay, so to include the tile map layer in our navigation region, there's a few different ways you could set it up. One would just be to take the tile map layer under navigation region and then go to navigation region and hit bake. So now basically anything that's a child of this can be included for its collision shapes and removing it from the navigation map. Or if you don't like having to set up the hierarchy that way, you can click on navigation region, go to navigation polygon, down to geometry, source geometry node, and you can do group with children. So you could either use this group name or you could just say maybe navigation and then click on tile map layer, go to node groups, add the group navigation, hit enter, or just add the group navigation. This can be a global group, sure. Hit OK. And now, because it has the group name, this and any child nodes of this should be included. If I hit bake, then it will work as well. So that's a couple ways you can do it anyway. Okay, so we can see that it does put quite a bit of distance between the actual collision shape and the navigatable region here. So if we hit play now, it'll sort of work in some ways. Obviously, it's getting kind of stuck there. So some of our setting we might need to tweak. So let's try changing the settings here to see if that affects anything. Right, okay, so we can see it's also trying to navigate over the wall, which, you know, on one hand sounds handy, but on the other does not make sense for a character that is not actually flying around. So we can definitely fix that. Let's go into the behavior tree for the AI and jump in here. So in our move, we're definitely getting the next path position. But when we get the direction to the move direction, we only actually want it to be the .x that gets passed along here because this is movement for a ground character. So we're going to say here vector2, and this is going to be the direction to .x, and the y is just 0. So a character cannot fly. It's just going to move along the ground. Okay, so if we hit play, we may see that our character gets stuck on walls like this if he ever comes all the way over here, because now we're only saying that the character can move to the right, even if technically the navigation agent would be able to navigate over to this using the A-star algorithm. So if we still want to use it that way, then we would want to jump at this point to have the character kind of jump over the wall, or try jumping at least. So we can just combine that, I think, into the navigation script. The ability for him to jump or not jump. Maybe the move directions actually, maybe the move and jump functions actually get pulled out of the logic here and just put on the main character as a function it can do, and then the logic just calls that function at some point. For right now, though, we'll just keep it inside of the AI script itself. So first, we're going to take this out and paste it in here. So we're going to get the next path position. So if the next path position has, let's say, the need to go up on the screen, then we're going to tell the character to jump instead of not jumping. So let's say if the next path.y, and let's pass the move direction into this over here. So we'll say the move direction or desired direction is going to be equal to this bit over here. Okay, so we pass in the desired direction into the move. So p desired direction at vector2. And then our move direction is going to be this dot x and 0. So if we actually call the move, we're just moving horizontally. Horizontal walk slash move action. All right. So that should work just like it did before. But what we're going to try to set this up is if the desired direction requires us to go up, then we're going to jump instead. Okay, so before we hit play and test again, let's click on Navigation Agent and enable debugging. So now when we hit play, we'll be able to see where it's actually trying to go to. So first off, it hasn't recalculated the path. So that is something it should be doing. We can also see, of course, that trying to get to this next point requires us to jump up, so we'll try to do that soon. But let's also recalculate the path. So in the AI script, whenever we get to here, before we do the next path position, let's say npc.navigation. Maybe it doesn't actually need to refresh the destination because the navigation map is still the same, so there's no need for that. Okay, but either way, yeah, we need to check the desired direction, and if the desired direction requires us to go up, then, so we'll say if desired direction dot y is less than 0, then we're going to try to jump. So we'll say jump, and then we'll try to move in the desired direction. We might say like else move, but let's see how that goes for right now. So making the character jump, let's say a variable jump, and we'll say that the npc.velocity.y is going to minus equals the npc.stats.jump velocity. And I think I am actually going to want to move these out from this navigation script to the NPC script itself. So let's jump into the NPC script and just paste these in here. So now all NPCs are going to have these functions they can call. And because it's in the NPC script, we don't need to have the NPC dot. We can just remove those because it's already implied that we're in the NPC calling these functions. So just remove the NPC. Let's go to navigation to point, and now we can do npc.jump or npc.move whenever we need. Okay, no colon there at the end. Okay, let's set a breakpoint here and see if that actually triggers. Well, it does immediately, right? So we also want to make sure that the character's on the ground before we do that. So let's say and npc dot is on floor. Okay, as a prerequisite to jumping. So let's close that, hit play, and well, do we get any kind of jump? It's still trying to jump. Maybe I had that wrong. Maybe it's supposed to be plus equals the stats.jump velocity. Let's try again. So we have jump occur, and it's not actually doing that, right? Okay, so like our move is setting the velocity, but really it should be only setting the x velocity, right? So yeah, we'll say move velocity is this. Okay, so here our move velocity has the direction times the stats.run speed. That's not exactly right though. I think we want to have another vector here. So it's going to be move direction dot x times stats.run speed and whatever the current velocity.y is. And that's going to be our new velocity down there. So that way, if our character's falling or jumping, we don't completely override that velocity. We're only affecting the left-right movement. And that should allow our character to jump again. So let's see if he goes over here to the right. Still not jumping. And that's probably because I did this. So let's do minus equals. Okay, and he went somewhere, so the jump's probably working. Yeah, okay, well, it kind of worked. Okay, let's hit play without any breakpoints. It shouldn't be able to keep doing that. So the problem here is that we don't have any gravity applying to the character. So at some point we need to apply gravity just like with the main player. So let's say function apply gravity. Let me just kind of grab that from the player script or wherever we had it. Maybe it was in character state. Yeah, okay, let's right click here and get that symbol. I'm just going to copy this over to the Krabby script. So that is going to be the Krabby script here. We have apply gravity. And just kind of paste that in there. I'm going to make this non-private just in case we need to apply gravity manually from any other script for any reason. So if the character's not on floor, so if not on floor, then we add the gravity velocity times the delta. So it's not character dot velocity, it's just get gravity and then times p delta. So I guess we would say that whenever we move, we want to apply gravity, for now at least. So that's going to be times the delta, huh? Well, for right now, I guess, let's just put in the physics process and apply gravity here by the delta. So now that should just be regardless of what's going on with the character, we're going to apply gravity. Okay, and there you can see he's jumping around, but gravity's actually affecting him. So we kind of got a crazy character going on here. Now he's not really navigating to anything particular, it's just picking random destinations. And I think we want to make it so that the y value has to be like over a certain point, right? So it should be like more than the angle that the character can move at, which by default is like a 45-degree angle that the character can just walk up a slope. So let's jump into navigation endpoint, and instead of the y direction being anything less than 0, why don't we say that the y value being less than 0 has to be greater than the absolute value of the left-right movement? So if that was the case, then that would imply, I think, that the angle is above a 45-degree angle, and therefore it wouldn't be able to just go up the slope here. If blocked on wall. Or maybe it should be more like if it's on the wall. Yeah, right. Okay. It's on wall and NPC dot is on wall. Okay. So if it's on the floor and the wall, then we'll try to jump. That might be interesting. Let's try that. Okay, there. Yeah, it just jumped over the wall once. That's a lot closer to what we want, right? And so that we can actually see it consistently, let's jump to the level, and I'm just going to put in a wall to the left here as well. So tile map layer, let's paint in a wall. So I think if I just like select these tiles over here, we can just paint it over here as well. And then we go to navigation region, bake, and there we have our wall on both sides. Okay, so yeah, the character is pretty much jumping over any obstacles like our character that it needs to in order to navigate to the point it's trying to get to. We can see here though, if the point is directly above the character, then it's not jumping. So let me see here. I guess what we'll say is if the point it's trying to get to is directly above the character, but we're not navigating over a wall like this, but like if the X movement needs to be 0, but we want to go straight up for Y, I'll just say that it fails the AI because we don't really want it to just be jumping in random places. So we'll say if, let's see, if the desired, okay, let's actually create a function for this because I think the logic might be a little complicated. If reached, okay, we'll say if reached horizontally, but if reached horizontally but vertical offset, okay, that is a terrible function name, but I'll create that for now. We'll put it down here. So function, if it's reached horizontally but vertical offset, then we're going to return a bool. So we're going to say if the, do we pass in the direction? I guess we'll just pass in the direction here. Desired direction is effective to. So if the p desired direction dot x is, well, let's see, can we do float but approximately 0? No. We want if is 0 approx, right? And then we say b desired direction dot x. So if the desired x is almost 0, then we've basically reached the point horizontally. And then if let's see, we kind of want like the distance. So should we be getting the distance? Bar distance 2 equals NPC global position dot distance to the next path. Then we can paste this in. P distance is float. If the P distance, you know what? We might not even need that, I think. So we'll just return true, else return false. Oh, I just returned false down here. We don't need to pass this into that, and we don't need this for now. We can calculate that any other time. Then we're going to return failure, because we've already reached the point we're trying to get to. So it could either be failure or success. It kind of depends on how you want to interpret that. But the point is that it's going to stop trying to do that move. It's going to move on with what it's trying to accomplish, so to speak. Okay, that's a little odd. What's going on there? Are we hitting that return failure? Okay, so I'm just kind of like hitting play now and watching it run a few times. Can hit F5 to refresh and just reset it. And I think for the most part, it's doing what we want it to, but obviously there's some weird quirks. It also moves kind of fast, so I might like slow that down. And we do want it to be playing an animation when it's actually moving. So let's add in the move animations. So the animation here for idle. Oh, you know what? Let's see, where should we actually have the animations being controlled? We could in the NPC have like an update move and idle animation function too. So let's see, update. Okay, play velocity animation, play movement animations. Right, okay. And you know what? Select movement animation. Animations might make more sense here. Pick some movement animation based on the current conditions of the character body 2D. So if the character velocity is approximately 0, then we will take the animation player. I think we already have reference to that on the NPC script. And we're going to play the idle animation. So let's put that up here at export var idle anim string name equals idle. So we'll play the idle animation. Else we'll play animation player dot play, and this will be the move run animation. So put that up here at export var run animation string name equals run, and let's just put that on physics process. So like we might change this stuff around later on, but I think that'll work pretty good for right now at least. So in our NPC, it should have been there. Maybe I need to refresh here. Okay, it's definitely an export variable. So I might just need to reload the project. Okay, so we have those animations. So if we hit play, it should be able to select between those. Okay, so it's moving, so it's playing the run animation. That's kind of what we wanted to see. Okay, and to go along with that, we can also have the facing. So kind of like this in the clown nose, we want it to be grabbing the direction variable from the blackboard. We'll actually do that kind of the same way as the facing script. I'm going to add an extra export here for, let's say, behavior tree, limbo BT, limbo behavior tree, or BT, what was it, BT player? Yeah, okay. So BT player. Okay, now let's throw this over on the Krabby script, or rather a child of it, node 2D. So now back on the Krabby scene, let's add in a facing node. So I did make that a class name, so that's pretty straightforward. And then this time we're just going to use the BT player instead of the Limbo HSM. But inside of the script, we'll just say that, okay, we'll say if Limbo HSM does not equal null, then we'll get the blackboard from that. Else if BT player does not equal null, then we'll get the blackboard from the BT player dot blackboard. I don't know if these inherit from a, hold on, Limbo HSM inherits from Limbo state. Yeah, so they have different base classes, so we can't just use like a parent class here. But this works well enough. So one script just covers both bases, and we need to get the direction var from the BT player. So the direction var on the BT player is not set up. So let's add in the direction var, which is the direction the character is trying to move in, which will be a vector 2. And now, as you might imagine, we need somewhere to set that direction. So if we go to the logic script, the behavior tree node, we're going to get that next path position. So the desired direction is the direction we're trying to move to. Right. So how do we want to do this? I guess we'll just say after we get the desired direction, we do blackboard dot set var bb names dot direction to the desired direction. And now the facing script should be able to access that from the blackboard as well. Let's hit play and see if it flips. Okay, that did not work initially. So BT player, we have that default value, right? Okay, got to make sure that the blackboard plans are kind of like the same. So gonna open up the enemy Krabby AI here, and it could just be that this blackboard doesn't have it. I see it there, so direction. And then on the BT player, it's like the same blackboard plan. It could be that the blackboard hasn't been set or something. Let me hit play here. We do get the BT player to grab the blackboard. Yeah, but that only seemed to happen at the first frame. Okay, now it's seeing that there's the direction var, but it's not setting the direction var, is it? Or is it? Hold on. I'll hit play. No, it should be facing to the right, but it's not. Let me try this instead. I'll make desired direction a local variable, and then we'll bind it. So desired direction is a vector 2, and on setup, we'll take the blackboard And we'll bind the var to the property. So bb names dot direction var, and it's going to be self. And then the property name is the desired direction. Okay, then we don't need to worry about setting it. So now this should be synchronized with the Blackboard. Let's hit play and see if that works at all. Nope, does not seem to. So I'll test the direction to see if it's getting set by doing a print on the blackboard.get var bb names dot direction var. Okay, so if we hit play now, let's hit output, and it's set to all kinds of things, right? But it's not flip. Oh wait, no, it is flipping the character, right? Okay, that's why print messages like that help. It's because we have nothing under the facing, so the facing isn't affecting anything. So if we just pull this up here, and we hit play, now the animated sprite is a child of the Blackboard, so it's going to actually flip because the facing node is flipping. But it appears to be going backwards, right? So if I do the idle animation here, yeah, this character happens to be facing the reverse direction. So, I mean, there's a bunch of ways you could fix that by like changing the sprites to all face the same direction, or we can change the scale here and make it -1.0 on the animated sprite 2D node. And if I hit play, well, that's going to work for us because we're just reversing the direction. Okay, yeah, that's working pretty okay. So I do see a bunch of little error messages coming from the animation player. We might need to check the idle animations and just make sure that these are still consistent. And then here we have run animation. Okay, so that seems to be working all right. So let's see, it can't resolve the reset track and can't resolve run. Okay, that's interesting. Okay, so it seems like if you just reload the project, it'll automatically resolve like the new path to the animated sprite 2D and so on and so forth. So don't need to mess with that really anymore. So yeah, once again, if we hit play, we got a character basically able to jump over the walls. It's navigating pretty randomly, but overall it does a good job of detecting when it's at the wall and trying to jump over it. So that's going to resolve this first video, setting up the navigation agent, the navigation map, and adding in one navigation AI task for our character. Going forward, we probably want to detect the player. So adding in a sensor node where we can pick up the player, move to it, and attack it as its own part of the behavior tree. So that's going to be it for this video. We'll get to that stuff in the next few videos and kind of wrap up our enemy. So thanks for watching. I've been Chris, and I will see you guys in my future video content.